What we're going to talk about is what we call the slope of a line. You notice that in all of the equations that we worked so far, some lines look like this, some of them look like this, some of them look like this, and so on. And you can describe how that line looks by the slope. It's exactly what it sounds like. It's like going up a mountain. A steeper mountain has a steeper slope, and a really flat, piece of highway or something has a very shallow slope. And we're going to use algebra to mathematically describe slope. What I'm going to do is I'm going to give you an equation to find the slope when you know 2 points on a line. So let's say you have a slope, 2 points like this. 1, 3, that's 1 point, and 2, 4. Now we could draw a graph and we could plot those points and we could get the line. But I'm going to define what I call the slope. The slope is also, for some reason, I don't understand why, but for some reason they use the letter M to describe slope. What it is it's what we call y2 minus y1 over x2 minus x1. The only reason I wrote this equation on the board like this, in this method, in this way, is because that's how it's written in the books. It's a very simple equation to understand, so don't let these little numbers fool you. All you have to do is you have to take, remember this is x comma y, you have to take the two y values and subtract them, and then the two x values and subtract them, and that's all you have to do. So let's do that for a second. Okay, let's take y2, I'm going to say 4 minus 3 over 2 minus 1. 4 minus 3 is 1, 2 minus 1 is 1, so the slope of this thing is 1. Okay, the slope of that thing is 1. Now, really, I'll just take a brief minute to explain why we're doing this, because it is kind of interesting. You have some line here, okay? It has a certain slope. In order to characterize the slope, you need to know how fast is the thing going up compared to how fast is it going over. Because obviously if it's going up really steeply, it's going to be moving up really fast compared to how it's moving over. And if it's really shallow, it's going to be moving up very slowly as it's moving over to the right. So what you're doing here is you're taking the two points on your line. Let's say 1 point was here and 1 point was here. You're taking the y value and you're subtracting them, and you're getting this distance right here. And that's how fast it goes up. And then you're taking the two x values right here and you're subtracting them here. Okay? And that's how far it moves over. And you're dividing these two numbers together, and you're coming up with kind of like a measurement of how fast it's moving up as compared to how fast it's moving over. Another really convenient way to remember this formula, M is equal to rise over run. How fast does the line go up, rise? How fast does it go over, to run? The only thing you need to be careful about when you do this, you can subtract the y values in any order that you want, as long as you do it consistently. And what I mean by that is the following. Let me just give you a quick example of what I'm talking about there. Okay, in this case we went 4 minus 3 on the top and 2 minus 1 on the bottom. You can also do it the other way, going this way. 3 minus 4, okay, and then 1 minus 2. Let's see what we get. 3 minus 4 is negative 1. 1 minus 2 is negative 1. Negative 1 divided by negative 1 is 1. You get the same value. It doesn't matter if you start subtracting 3 minus 4 from this point, subtract to this point, as long as you do it the same on the x. Again, you can go the other way. 4 minus 3 as long as you make it 2 minus 1. You just have to make sure that whichever point you're starting from, you start from the same way when you subtract on the bottom. So if you go from this point, subtract these numbers, that's fine, do it that way. But if you start at this point, subtract these numbers, that's fine, you can do it that way, as long as you're consistent. Okay? So that's the slope of, that's really the slope of a line. You just need 2 points to define the slope. We can just do a couple of additional problems. What if you had 0, negative 5, and 4, 3. Again, it's equal to rise over run. So you got to subtract the y values and then the x values. So I'm going to do it this way. I'm going to say 3 minus negative 5 over, and I went this way, 4 minus 0. So I've got to go the same way. 3 minus negative 5, 4 minus 0. Got to go the same way. Anytime you have minus a negative number, it's kind of like adding the opposite. So you can put pluses there. Okay? So 3 plus 5 is 8. 4 minus 0 is 4. So the slope is just equal to 2. Okay? Okay, another problem. Let's say we have 2, 3 and negative 3, 2. Okay, so I could say m is equal to 2 minus 3 over negative 3 minus 2, negative 3 minus 2. 2 minus 3 is negative 1. Negative 3 minus 2 is negative 5. So then when you do this, negative over negative is always positive, so you just get 1 over 5. Okay? Most of the time, when you find the slope of something, it's going to be a fraction. Okay? Most of the time it is. And all this fraction means is that, remember, it's rise over run. Rise over run. Okay? So what that means is, every time I go up, I go over 5 times. So you can kind of think of it that way. Every time I go up 1 unit, I go over to the right 5 units. And that's exactly what the slope is really just trying to convey. It's just a fraction, you know. And sometimes whenever there's no explicit fraction there, if the slope is just equal to like 2, never forget that all numbers can be written with a 1 on the bottom.